In 1967, a postgraduate student at Cambridge University by the name of Jocelyn Brunel was surveying the sky with a newly constructed radio telescope. After a few weeks, he discovered something. The telescope had picked up a radio signal that seemed to be pulsating. The pulse had an interval of exactly 1.33 seconds, and we and were initially thought to be nothing more than man-made interference. However, it soon became clear and that the signal did in fact emanate from deep space. The unwavering precision of the pulses was unlike anything seen before. As such, many questions whether it was a natural occurring phenomenon or a transmission from another civilization. The radio source was even named LGM-1 as an acronym for the Little Green Man, and Brunel herself, could not help but wonder if she actually discovered the first sign of life beyond the Earth. As you might expect, it didn't take long for natural explanations to emerge, and we now know that these pulsating signals to be produced by rapidly rotating neutron stars known as pulsars that emit beams of radiations akin to the beams of light emitted by a lighthouse. If nothing else, it made for a neat album cover. Ever since an international effort known as the Search for Extraterrestrial Intelligence has actively been listening for artificial transmission. But so far as we appear to be the only ones broadcasting into the void, humanity has been leaking radio signals since space for the better part of a century. So any eavesdropping aliens within about 100 light years could potentially be alerted to our presence. Beyond this invisible radio bubble enveloping some 15,000 stars, the Earth is just another silent speck. Not only that, but as technology improves, this radio leakage is dramatically reduced. Long before Earth may return to a state of radio silence, if most civilizations improved and eventually outgrow radio technology at a similar pace, the radio signature of any civilization may be detectable for a very brief period of time. However, furthermore, this radio leakage is extremely faint and only grows more and more diffuse as it expands into the galaxy. Some of the most powerful signals to leak into space are military radar emissions and stand a much better charge for detection across interstellar distances than the average television broadcast. The square kilometer array, a vast interferometer to be constructed in South Africa and Australia, could be sensitive enough to detect the faint radio signatures of Earth-like civilizations. Out to distance of several hundred light years to detect more distant signals, more signals would require more deliberate attempts at communications. For instance, advanced civilizations may construct powerful beacons, especially to increase their radio luminosity. These beacons would either become expensive to maintain as they would consume vast amounts of energy for extended periods of time. A less expensive alternative would be a focused beam of radiation as opposed to omnidirectional broadcast. In 1974, the Arecibo Observatory in Puerto Rico famously beamed an interstellar message towards a global cluster some 25,000 light years distance. The message took less than 3 minutes to transmit, so any prospecting aliens in the path of that signal would have less than 3 minutes to detect it, as they will never get a second chance. They, we may have been on the receiving end of such of interstellar message when in 1977 a momentary burst of energy swept across the planet. Repeated attempts at detection, notwithstanding the famous wow signal, was never detected again, and its origin has never been conceivably ascertained. On the same stars that it was artificial origin, A reply was being interchanged at direction when it came in 2012. A galaxy as old as and vast as Milky Way, and the probability of two civilizations stumbling upon one another by briefly screaming in random direction is not great. To increase our chances, we need to limit our selection of targets by searching for other technological and biological signatures. In 1995, the first extrasolar planet orbiting a Sun-like star was discovered. We know that the vast majority of the hundreds of billions of stars in the Milky Way galaxy are home to be at least one planet. We also know that billions of those planets are of similar size to the Earth and orbit within the habitable zone of a star similar to the Sun. This means that liquid water could exist on the surface, which is an essential ingredient for life as we know it. Furthermore, billions of extra solar moons may also be capable of supporting life. With this knowledge in mind, in 2017, a message was being towards one of the least distant and most Earth-like exoplanets discovered to date. The message comprised a number of musical compositions and basic information about the humankind. And should the planet be inhabited, we could expect a reply as early as 2044 as a quick preview of that future. However, habitability is no guarantee of habitation. To determine whether a potentially life supporting planet is currently supporting life would require a more careful examination. For instance, by analyzing starlight passing through the atmosphere of an exoplanet, it is possible to deduce its chemical composition. The spectrum of oxygen-rich atmosphere will differ from that of, say, hydrogen-rich atmosphere. Given that photosynthetic plants and organisms are responsible for the large quantities of oxygen on Earth, an extraplanetary atmosphere with similar concentration of oxygen could be taken as a sign of life. This is known as biosignature, but it is far from definitive as oxygen could be as a result of various abiogenic processes. As such, astrobiologists are more interested in certain chemical combination as it would be far less likely for, say, methane and carbon dioxide to coexist in the absence of life. Speaking of carbon dioxide, some chemicals could be indicative of industrial pollution and thus artificially induced climate change could serve as a universal sign of unintelligent life. In addition to biosignature, we may be also able to detect signs of technology. For instance, an exoplanet surrounded by dense orbital belt of artificial satellites or space debris could be detected during transit of its parent star. This would be an example of technosignature. A more extreme example would be a megastructure. The initial speculation surrounding the discovery of pulsar has become somewhat of a recurring theme. When, a, when an astronomical discovery is initially defies explanation, vigorous speculation about aliens is taking center stage. In more years, this discussion has been dominated by a peculiar star, some 1,500 light years distant. The star exhibits erratic light fluctuation and occasionally dim as much as 22%. One hypothesis is that the alien megastructure is blocking the light from the star. While evidence of extra engineering is still within the realm of possibility, the damage is now thought to be caused by nothing more than dust. The existence of circumstellar megastructure was formalized by theoretical physics Freeman Dyson back in 1960 as a potential means for advanced civilizations to harness the energy of the parent star, commonly known as Dyson sphere or Dyson swarm. According to the Kardashev scale, a method of measuring a civilization's energy consumption, proposed by astrophysicist Nikolai Kardashev in 1964, a Dyson sphere would be indicator of Type 2 civilization, as a Type 1 civilization could harness the energy of its own planet. A Type 2 civilization could harness the energy of its parent star. A Type 3 civilization could harness the total energy output of an entire galaxy. Extensive surveys of billions of stars notwithstanding, there is no reliable evidence of a Type 2 or not Type 3 civilization in the Milky Way galaxy so far. So, what extragalactic life after serving 1,000 stars for signs of Type 3 civilization? Astronomers found no signs of a galactic empire. The great silence of the universe can be a bit unnerving. Humanity is now on the verge of detecting biosignature on extrasolar planets, but Earth has been radiating detectable biosignature for billions of years. Yet, as far as we can tell, it failed to detect the attempts of many alien astronomers. The apparent contradiction between the exploration and the lack of evidence for extraterrestrial life is known as Fermi paradox. Given the sheer size and the age of the universe, why does it appear to be lifeless? Is it so possible? It is possible to concoct a, my- a myriad of hypothetical solutions. Perhaps life is common while intelligent life is exceedingly rare. After all, it took some 4 billion years of evolution and a number of mass extinctions before humans emerged on Earth. Proponents of the rare Earth hypothesis suggest that complex life on Earth is the result of a probable chain of events likely to occur more than once. Therefore, the existence of barrier either improbable or impossible for life to overcome. If the barrier is behind us, we may be among the fortunate few to have crossed it. Potential candidates include the emergence of multicellular organisms and the invention of the nuclear weapons. If the barrier is still to come, we may soon join the cosmological graveyard of fallen civilizations. Potential candidates include unstable climate change, the invention of the nuclear weapons. Perhaps we severely underestimate how truly aliens can be. All life on Earth is carbon based and rely on water, but life could hypothetically be silicon based and thrive in oceans of liquid ammonia. Just as we search for life we know it, aliens may be doing the same. Perhaps an advanced civilization did in fact pay us visit in the distant past, unless some sort of evidence of that visitation survived for millions or billions of years. We never know. Even a visitation in the distant past could have been misconstrued as cause descending from the heavens. Well, I mean, that could be a fairly accurate interpretation. Perhaps all civilizations inevitably develop technology that transcends physical reality. For instance, reality could be rendered obsolete by hyper-realistic simulation. By transferring one's consciousness into the virtual wonderlands, one could achieve digital immortality. The happenstance or offering of nature could struggle to compete with the promise of utopia. Throughout galaxy, pockets of advanced civilizations may occupy no more than a few star systems. As they explore the inner space in place of outer space, in the transaction of hypothesis for futurist John Smart takes a step further and supposes this introverted evolution will progressively miniaturize computers until they are intensely compressed that they generate an environment analogs to black holes. The post-biological and civilization thus could would thus transcend the space-time continuum and vanish into the visible universe. Hypothetically speaking, apart from the artificial transmission and distancing science of astroengineering, there's also far less remote form of techno signatures. The Voyager spacecraft was launched in 1977, and as far of making this video, it is the only probe to have reached interstellar space. It famously carries a coded record with information about humankind, but it will take another 40,000 years before the probe encounters another star. In an effort to more expediently explore the galaxy, and advanced civilization may launch sophisticated interstellar probes capable of self-replication. These probes would be intelligent enough to mine the available resources in any given planetary system to create copies of themselves. These copies would then travel to neighboring systems and create additional copies. If these probes could travel at just 10% of the speed of light, a speed attainable by modern methods of propulsion, every corner of the galaxy could be exhaustively explored in just a few million years, a relatively short amount of time on a cosmological timescales. Minecraft is now fast approaching the technological sophistication to launch such a probe. This begs this question: why is the solar system so probeless? If human progress is an indication that the galaxy should be completely overrun by self-replicating automata, yet we see no evidence of that. An ongoing hunt for alien artifacts has yet to locate any covert probes tracking in the solar system, but space is vast. An object of extrasolar origin could easily be sweeping around our cosmic backyard without our knowledge. In fact, that is exactly what happened in 2017. Extrasolar object named Unamia passed through the inner solar system and went completely unnoticed until it was moving away from the sun. Even then, its discovery was pure luck, and thousands of extrasolar visitors could have been undetected each year. The size and the shape of Unamia could only be interfered by the amount of light it reflects, but it appears to be highly elongated or extremely flat. Initially, it was thought to be a comet, but the absence of a cometary coma, a trailing cloud of dust, and a gas typically formed when comets approach the sun, lent credence to it being an asteroid. But as the object began to accelerate, this acceleration would be consistent with the outgassing of the comet. But as mentioned, Unamia does display the expected characteristics of a comet. One possibility be one possibility is that the outgassing is simply too faint for us to detect, and there is that remote possibility of that being a interstellar probe. More specifically, more specifically, a probe using a light cell as a means of propulsion. On the other hand, Unamia is perfectly radio silent. Perhaps it is defunct probe destined to aimlessly roam the galaxy, much like Voyager. It is important to remember that with the sample size of one that being Earth, we cannot possibly know that common or rare life truly is. There could be hundreds of planets or millions of galaxies between us and them. If life was discovered elsewhere in the solar system, perhaps beneath the frozen mantle of Europa, we will be able to compare the contrast between two distinct sources of life and gain crucial insight into the com- commonality or rarity. Many reject the anthropogenic view of Earth as a cosmological oddity due to the sheer number of Earth-like planets coupled with the resilience of life on Earth. But the truth is, we don't know. We don't know if billions of planets is sufficient for intelligence to arise more than once. We don't know for the prerequisites for abiogenesis, the transition from non-life to non-life, non-life to life. We don't know the probability of cosmic solitude. But to conclude that we are alone in this face of all the ignorance is more than a bit of a substance. The extent of our search of extraterrestrial intelligence has been compared to searching a glass of water for evidence of fish in all the oceans. Space is unimaginably vast, and we have barely begun to scratch the surface. There is so much untapped evidence for detecting the signs of life that if we just turn the telescope a bit to the left, made it a bit larger, and listen to a different range of frequency, perhaps the universe wouldn't be so silent.